Good morning, everyone. This morning I'm going to explain to you the mid-ordinate rule. Through further maths, there are two ways we use to estimate the area under curves. In this video, I'm going to talk about the mid-ordinate rule, and shortly in another video, I will talk to you about Simpson's rule. These are additions to what you learn in normal maths, the trapezium rule. Now, the mid-ordinate rule. As you can see here, I've got a function that I have drawn, y equals fx. And what I have done is I have drawn rectangles where the midpoint of each of the rectangles is on the curve. So we have these midpoints. So the idea behind mid-ordinate rule is that we work out the areas of these rectangles and we use that to estimate the area under the curve. Each of the rectangles would have equal width called h. So that means to work out h, we do b minus a divided by the number of strips. So in this case, I have 4 strips or 4 rectangles. So whatever these two values are, I would need to split it up. In addition, we would also need to know the heights of each of these bars. So the height of this bar would be f of this midpoint, and this one would be f of m2, f of m3, and f of m4. So for me to approximate this area, the approximation between A and B would be approximately the width of the bars multiplied by f of m1 plus f of m2 plus f of m3 plus f of m4. Okay, so typically this section here we denote as just big M and a little n there to say how many strips we had. Okay, as you can see, it is quite straightforward. So let's actually do an example. So here's the figure I've drawn, which is y equals the cube root of x, the square root of x cubed plus 1. We're going to use the mid-ordinate rule with 4 equal strips to estimate the area between 0 and 1. So the key thing is I'm having 4 equal strips and I'm going between 0 and 1. I'm not doing the full diagram which is drawn here. So first of all, 4 strips between 0 and 1, so the h equals 0 plus 1 divided by 4, which is 0.25. That means my values for the midpoints would be, well, if we're starting off this at 0, the first midpoint is at 0.125, because if we're starting at 0, we're halfway into that group. So from there, I'm going to add on another 0.25. So my next point is at 0.375. My next midpoint is at 0.625. And my last midpoint is at 0.875. So because that is my width, I've halved it, added it onto my lower limit, which is 0, and therefore I've got my 4 midpoints. I now find out the y-coordinate to go with each of them. So each of these will get typed into the lovely calculator, which I'm just doing off screen. And because the answer is to 4 significant figures, I'm just going to keep a couple of extra decimal points in here while I do it. So I'm working out the heights of each of these rectangles. which gives me these values here. So the integral, I'm going to scroll this down a second, between 0 and 1 of x cubed plus 1 dx is approximately, don't forget these are rectangles, so we take the width of the rectangle, 0.25, and we're going to multiply it by each of the heights. Which will come out as 1.1, just off the bottom of the page again, 1.109. This method is quite straightforward and it's definitely worth